If you were at this point at the Poplar St pump station about 150 years ago, you'd be on the shores of the Millers River. The Millers River was the border between Cambridge and Somerville, since the glaciers had their way through this area, and was also the receiving point of all the runoff and sewage waste from a good portion of Somerville and Cambridge for that, intervening 150 years since the area was colonized. By the late 1800s, it had become so polluted it was a public health hazard, and the cities of Cambridge and Somerville petitioned the state legislature to fill it. The state legislature allowed that filling and funded the construction of what is now called the Cambridge Branch Sewer to take all of that sewage out into Boston Harbor. But it did also create sort of a constraint for this area of Somerville, Union Square. Because the capacity of that pipe was limited, this area of Somerville and Cambridge would often flood. That was an insurmountable problem for many years because while the railroad system had their own drainage system, they weren't very receptive to Cambridge or Somerville tying into that. That was until the GLX project came along and the MBTA needed additional funding to get it over the finish line and bid it. They were looking for $50 million from Somerville, which Somerville pledged, with a requirement that we be allowed to tie into their system that they were improving. We brought on Stantec to be our engineer to design the pump station because our system is lower than that MBTA system, so we have to pump up into it. We also did a whole bunch of work with Stantec on understanding our system and the root causes of flooding. And we determined that if we also built a storage tank, we could maximize the use of that connection. And pretty much every gallon of storage we could build here would be a gallon of flood that we could reduce in Union Square and the surrounding neighborhoods. We've got an excellent team out here. We're working along, and when we're finished, we will fundamentally change the way we're able to handle stormwater in the Union Square area and unlock potential to reduce flooding in that key area of the city that otherwise would not have been possible.
One of the advantages of the tank technology that is uses a lot less concrete, and so it's a lighter weight structure, and so we don't have as much mass to counteract buoyancy. There's groundwater conditions. Once we're done and we bury this thing, groundwater will stabilize and the tank's going to want to float. So that's when it's a very common technique to help anchor a large underground structure. You're right up there.
They put these big steel sheets in the ground, drive them into the rock, and if you look over the edge, you can actually see down in. They put these.
Oh wow!
Yeah, these big sheets get driven into the ground, then they put these They have these ring beams in that basically kind of keep the whole thing in compression all the way around the whole perimeter of the tank. So there are 3 of those, and they get out about 40 feet to the bottom. You can actually go down. There's actually a stair that goes down, and you can actually walk all the way around the outside of the tank, all the way down. And you can get in.
There was a whole process where we pre-characterized the site, so we basically took a lot of samples.
Yeah.
To a standard set by the state to figure out what each of those samples consisted of, and then we basically worked with MWH to arrange for which landfills would take that material, and it was identified on a grid, and then we basically excavated certain areas and trucked it off to one site and excavated others and trucked it off to other locations.
It's that when everything gets poured and it starts to cure, they actually tighten those cables up.
Yeah, the technology that you see here is called post-tensioning, and it's a technology that's actually been around for quite a while, and it's been involved in building and bridge construction since the 60s. And it was in around 2006 that one of the major governing bodies for wastewater infrastructure certified this technology for use with sewage storage tanks, and that's where it allowed to start to be applied to projects like this. So it's a relatively new innovation for the market that the city's taken advantage of. And to my knowledge, having been involved in this project since 2019, it's the largest underground post-tension tank of this type in North America. So it's remarkable in that respect as well.
We're super cutting edge for something that was developed 65 years ago.
Yeah.
It's a pretty amazing operation to watch go on. They do it's really a very synchronized and very takes a lot of effort. They make it look easy. It's a lot of hard work.
So that is the wall of the tank.
Oh, cool.
That was just the supportive excavation.
Okay.
So this gets refilled, just probably with like flow fill. Like it's a really low density concrete that will like flow like water, but then solidify. The sheeting has to get pulled because you can't leave the non-American steel on the site.
Inside this thing.
So that's just a wall that sort of bisects the tank. Because the tank is designed different flow rates depending upon how much rain falls, and we've got a screening facility at the front of it, so large debris will get screened out before it comes into the tank, but invariably there's going to be a lot of suspended solids in the stormwater that will settle out when the water is being stored in here. So from an operations and maintenance standpoint, we wanted to have one side of the tank activate more frequently, which would then mean that water and sewer is going to have to come out and clean out that sediment. But the other side of the tank will only activate in very large storms. So water and sewer won't have to clean that side as frequently. If you look straight down here, that's actually the low point of the tank. So that the floor of the tank has a slope to it, so that the water flows towards that low point. So the suction point is right down there. And then this void space gets filled in at the end.
When is the 4th?
3-minute tour, guys.
Week after next.
Yeah.
And so I can only imagine, so it's week after next, it's poor. How many trucks do you have coming up at the same time?
A lot. We have 2 pump trucks going at once, and both pump trucks have 2 cement mixers all ready to go, and then the others are behind them. So we always have 4 on site.
Okay, and then the 4, what will that do? Like achieve maybe an eighth of this top,
they'll have one pump truck on one corner, one on the other, and they're just
You're just doing.
does the math. It's 1,000 yards of concrete, so there's 10 trucks going through there. So
Wow.
it's quite a few.
Yeah.
You see 1 and 3? They're going to go inside each of those. So everything's being laid out right now. Eventually, this will be pushed out through that hole.
And where do these cables get tied into?
Those are called seismic cables, so they kind of just get spread out like they are currently,
Yep.
and they bond with the roof slab.
And those are the ones that come up through the columns.
These
No?
guys?
These.
They just have these in the wall,
Oh,
and so
okay.
what these do from
Oh,
you know.
those are the columns.
Yes.
Yeah.
Yep,
Okay.
exactly. Those are the columns right there. So this is a column.
Yep.
These are for seismic events. So the roof slab is the way the D115 design works for this type of tank is it's not rigidly connected to the walls. Jonathan was talking a little bit about this, but the reason for that is it's actually the concrete. So this is the top of the wall right here, right? And there's
Yes.
a rubber
Yep.
material. So the concrete for the roof does not bond to the walls because when they go to stress it, when they pull on these tendons, the whole slab
Yep.
actually moves.
Yep.
It's actually allowed to move a little bit on
Yep.
top of the wall.
Makes sense. Yeah, that seems. And then I guess when you were talking about the rubber membrane on top of the outside wall, I was looking at this is a plywood that has some sort of finish on it. Do you need to have a certain material type in order for the concrete to lay on it, or is it shiny and smooth in order to allow for movement? I don't, you know.
I guess I would say both. You want it to be able to. This does not stay here. So after the concrete
Oh, I
reaches
see.
strength, they need to be able to remove it. So
Okay.
you don't want the concrete to bond to this wood. Otherwise, you'll have a hard time stripping it off.